Have you ever wondered how an app can go from just a few users to millions seemingly overnight without just completely crashing and burning? Well, it's not magic. It is a very carefully orchestrated dance of automated scaling. So today, we're going to climb what I call the scaling ladder and see exactly how it's done. Okay, picture this. You launch your new app, and suddenly, it's everywhere. A celebrity tweets about it, you hit the top of Hacker News, and the traffic is just exploding. This is the dream, right? This is your moment. Or is it? Because that tidal wave of new users brings a massive, crushing load on your servers. And if you don't have a plan, that dream turns into a total nightmare of error messages and a crash service, right when the whole world is watching. Yeah, this is what we call a problem of success. That totally unpredictable, massive spike in user demand, that's the core challenge we're really tackling here. How do you build a system that can actually handle a tsunami of traffic without breaking a sweat? Well, the solution really boils down to a two-layered approach. First up, you've got application scaling. Think of this as just making more copies of your app to handle all the incoming requests. Then you've got infrastructure scaling, which is about adding more raw computing power for those copies to run on. You absolutely need both of these working together. All right, let's start with the very first rung on our scaling ladder. This is your fastest first line of defense, and it's all about scaling the application itself, using something called pods. So in the whole Kubernetes world, a pod is basically the smallest little unit you can work with. Now, to make this super simple, let's use an analogy. Just think of a single pod as one cashier at a supermarket, handling one customer at a time. So if our pods are the cashiers, who decides when to open up more checkout lanes? Well, that's the job of the horizontal pod autoscaler, or HPA for short. It's like a really smart store manager who's constantly watching the lines. And as soon as they start getting too long, poof, it automatically calls in more cashiers, or in our case, it launches more pods. So how does the HPA know the lines are too long? It watches metrics. And the most common one by far is CPU usage. You can set a really simple rule, like if the CPU usage on our existing pods climbs over, say, 80%, that's the trigger. Time to add more. It's a simple but really powerful idea. Now this system, it works brilliantly, but only up to a point. Your store manager can keep opening new checkout lanes, but what happens when you just physically run out of room in the building? You can't add any more lanes. Now you've got a much bigger problem. And this brings us right up to the next rung on our scaling ladder, scaling the nodes. See, this isn't about adding more copies of the app anymore. This is about adding more of the underlying infrastructure, just more raw power. A node is the actual server. It could be a physical machine or a virtual one where all your pods live. So, to stick with our analogy, if the pods are the cashiers, the node is the entire supermarket building. If you want to add more cashiers, you might eventually need to build a whole new extension to the store. And to automatically expand our supermarket, we have a couple of tools. The classic one is the cluster autoscaler, which adds predefined types of servers. But a much more modern tool is something called Karpenter. It's way faster and way more flexible. It's capable of getting the exact right-size server just in the nick of time. Think of it like the difference between building a standard one-size-fits-all extension versus a custom-built wing that's perfectly designed for your exact needs. So we have all these powerful tools, but they don't just work by magic. You have to write the rule book for them, and setting them up correctly involves some pretty critical decisions and trade-offs that honestly can determine whether your whole system succeeds or fails. Okay, now this is where you can really see it all come together. A traffic spike hits, the HPA sees the CPU usage climbing and immediately tries to add more pods. But wait, there's no room for them. That's when a node scaler like Karpenter sees those new waiting pods and instantly provisions a brand new node. And just like that, the new pods have a home, and the crisis is averted. The whole thing can happen in minutes, sometimes even seconds. You know, this level of automation means you can get way smarter than just watching the CPU. You can actually configure your scaling based on your business logic. Imagine scaling a video processing service based on how many videos are waiting in the upload queue. This lets you align your infrastructure costs directly with your business activity. It's pretty cool. And all of this leads to a really crucial point, this fundamental trade-off between cost and performance. On the one hand, you can scale super aggressively, always having extra capacity ready to go. You get amazing performance, but it's expensive. Think of a big e-commerce site during a flash sale. You have to have that capacity. On the other hand, you can scale conservatively, waiting till the last second. This saves a ton of money, but you risk slowdowns. That might be a much better choice for something like a background data processing job. There's no single right answer here. It's a business decision. Now, a quick but really important warning. Getting these rules wrong can be, well, catastrophic. A bad configuration could literally cause your system to scale up infinitely, leading to a shocking cloud bill. Or it could fail to scale at all, leading to a total system outage. Precision is absolutely key here. So how do you get this right in the real world without blowing your budget or your service? It really comes down to setting up what we call production-ready guardrails to make sure your scaling is both effective and, safe. Here's a fantastic starting point for most production systems. You'll want to use the HPA, targeting around 70 to 80% CPU usage. Pair that with a modern node scaler like Karpenter for that speed and efficiency we talked about. And always set up budget alerts and put maximum limits on your cluster size. These are your safety nets. Don't skip them. So let's just lock in the key takeaways from all this. First, remember to use a layered defense. Scale your pods first, and then scale your nodes. Second, let automation be your best friend. Use tools like HPA and Karpenter. And finally, never, ever forget that fundamental trade-off. Every single scaling decision you make is a balance between performance and cost. So we've seen how all this incredible automation works. The system knows how to add more capacity when it's needed. But that leaves us with one last really crucial question. Who defines why it's needed? And that's where technology meets business strategy. And that, my friends, is a decision that can't be automated.